topic is sequence, series, and progression. So first we'll try to define, there is a small difference among them, but ultimately we are going to look at the progressions and types of progressions and solve problems based on the progression concept. Okay, so first we'll see what is a sequence. All right, so succession of numbers arranged in a definite order, okay, or arrangement according to a well-defined law is called as a sequence. So we can write a succession of numbers arranged in a, a definite order is called sequence. So whenever we try to write the sequence, right, it can be in a specific order. So for example, this is 2, 3, 5, 7, 11, 13, and so on. This is a sequence. Okay, so we cannot write any formula for the sequence, but there is a order for that, right? This order of prime numbers, right? So the types of sequences are as follows. The first type of sequence is called as a finite sequence. So when we say finite sequence, it has a finite number of terms. So it is a series with the finite number of terms. So if I write say first five prime numbers, so it's a five numbers, so it's a finite. Whereas if you try to write the uh, sequence with infinite number of terms, then that will be called as infinite sequence. So you're going to have infinite number of terms in it. Right. Such a sequence will be considered as a infinite sequence. Infinite. All right. Then there is a variety of sequence which is going to be called as a series. Right. So in a sequence, the sum of all the directed terms is called as a series. Right. So it has to be a sequence first. So in a sequence, in a sequence, the sum of the directed terms. So this is called a series. This will be called as a series. For example, if I write 1, 4, 7, 10, 13, 16, etc., it's going to be a sequence, but if I try to write 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus dot dot dot, etc., right? This is going to be a series. So we can see that there is a difference between the series and a sequence. So once again, we have two types of series coming into picture, right? The first one will be finite series, right? A series with finite terms will be called as finite series, and you are going to get another one that is infinite series, right? So one has finite terms, other has infinite terms. All right, then we go for the third one. This is called as a progression. Right. If the terms of a sequence can be described by any explicit formula, right? Then we are going to call that sequence as a progression, right? So it has to be a sequence, and the terms of the sequence should be described by a formula. Okay, so if the terms of a sequence can be described by an explicit formula, right? Then the sequence is called as, then that particular sequence will be called as a progression. So this is the definition. For example, if I try to write 1, 3, 5, 7, etc., you see that I'm adding a specific number to the previous term to get the next term, and so on. If we are able to write something like this, right, then that will be called as the progressions. All right. Right, now let's go to the specific types of progressions. The first type of progression is called as the arithmetic progression. So this is the arithmetic progression, generally denoted by AP. All right. So in AP, the difference between any two term and, right, difference between any term and its preceding term, right, the term before it, is going to be a constant throughout. So we can write here the difference between any term and the term before it is a constant. So normally we call that as the common difference denoted by D. Okay, so let us try to uh, write a sequence, right? And we'll try to convert that sequence into AP, right? So if I try to write T1, T2, T3, dot dot dot, right? You can have maybe up to nth term Tn, right? So if the Tk minus Tk minus 1, the current term and its previous term, is equal to D, right? For for all values of k, right? K can be 2, 3, 4 up to n, right? So for all k is equal to 2, 3, 4, dot 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 up to n term, then this is called as the AP, right? So D is equal to, you can try to write T2 minus T1. This is also equal to T3 minus T2. Okay, that is also equal to, you can write the last one, that is Tn minus Tn minus 1. So if this particular relationship holds good, then it is called as AP. All right, now let us see. We can also, there is another way, right? Uh, this is a note. So arithmetic progression can also be represented in the following format, right? So if A is called as the first term, A is called as the first term, then anyway D is known as the common difference, right? Then AP can be written as, you can see the AP can be, it is the first term. The second term is A plus D. The third term is A plus 2D, right? Like that, what should be the nth term? It is A plus 1 less than the term. So this is third. So I have second. This is the second term. So A plus 1D. So this is the first term. So A plus 0D. Like that, the nth term has to be A plus n minus 1 into D. So this is A plus n minus 1 into D. Right. Now, if we add the common difference to any term of AP, we are going to get the next term. And if you subtract the common difference, you are going to get the previous term or the preceding term. Right. This is one feature about the arithmetic progression. In addition to that, the common difference in arithmetic progression can be positive, zero, negative, and imaginary. Right. So that's another point to remember, right? The D can be, it can be positive, it can be negative, it can be zero, or it can be imaginary, right? So this is the feature, another feature. Then we have a, we have varieties of APs coming into picture. Inside AP we can have variety. So first one is D, right? If D equal to 0, then you call the AP, right, as the constant AP, right? Because it's not going to change its value, right? Difference is difference is 0. So all the values are A. At the same time, if you have D as any constant value, right? I can try to write in this way, any constant value, say greater than 0. If D is more than 0, then the AP is called as an increasing AP. At the same time, if at all the D value becomes less than 0, D is negative, right? This is called as decreasing AP. Then we have the D as imaginary. If the D becomes imaginary, the AP is also going to be imaginary. So we are going to call that as imaginary arithmetic progression. Right. Now, the next point is if a sequence, if a progression is given, right, and we want to determine whether that is AP or not, right? So, to find if a given sequence is AP or not. So if you want to find this, then I'm going to do this, right? We directly try to obtain the nth term of the sequence. All right. So first, my objective is to find the nth term of the sequence. All right. That is maybe we can denote it as Tn. Right. Then in the next step, we are going to replace n by n minus 1. So replace n by n minus 1 to get Tn minus 1. Right. And the step number 3 is find the difference. Find the difference, that is Tn minus Tn minus 1. So take this difference and calculate and keep it ready. Now once I have this difference with me, now I can decide whether the given sequence is AP or not. So how to identify? So let's say if the value of this term, that is a difference, Tn minus Tn minus 1, if this difference is independent of n, so there should not be any term n, right, in that answer, right? If the value of this difference is independent of n, then you can say that the given sequence is AP, right? This implies the given sequence is AP, right? Else it is not AP. This is an AP, so else this is not AP. So I just have to do this job. All right. All right. Okay. Let's solve a quick problem based on this concept, right? So if nth term of a sequence is Tn equals to 5n plus 4. Okay. Uh, check whether the sequence is AP or not. So we'll directly move on to the steps we mentioned here, right? Obtain the nth term Tn. You can see that Tn is already given, right? I can simply write that as it is. So in this case, the Tn is given and its value is 5n plus 4. Okay, now we just have to replace n by n minus 1 to get the Tn minus 1. So this implies Tn minus 1 has to be, this is 5 times n minus 1 plus 4. Okay, so I can simplify this as 5n minus 5 plus 4. So Tn minus 1 is 5n minus 1. Okay, Tn is that, and Tn is 5n plus 4, Tn minus 1 is 5n minus 1. So this implies I just have to calculate the Tn minus 1. So what is Tn? Tn is 5n plus 4. That's the first term, minus the second term, that is 5n minus 1. So expanding, 5n plus 4 minus 5n plus 1. So 5n minus 5n cancels. So we can see that this is equal to 5. So what is the condition? I just have to check this difference value. So it says that if at all the difference Tn minus 1 has no n in it, there should not be n present. If at all your term does not contains any n or any other format of n, like n square, root n, there should not be any n. So you can see that this is a constant, and right now what we have is independent of n, right? So this answer does not contain any n, right? So the given sequence is AP. This implies given sequence is arithmetic progression. Okay, so very similar. I'm going to give another question to solve now. So let us say that Tn is given by 3n squared plus 2. So check whether the sequence is in arithmetic progression or not. So Tn is given like this. So I have to replace every n by n minus 1 to get Tn minus 1. So this is 3 times. See, you are replacing n by n minus 1. So there is a n minus 1 and then square plus 2. So let us expand this. This is 3 times. What is n minus 1 square? That is n square plus 1 minus 2n plus 2. So this is 3n square plus 3 minus 6n plus 2. So Tn minus 1 has to be 3n square minus 6n plus 5. Okay, this is the Tn minus 1. So perform the difference now. So Tn minus 1 has to be equal to, this is 3n square plus 2, that's the first term. Then subtract 3n square minus 6n plus 5 from this. So this becomes 3n square plus 2 minus 3n square, minus of minus is plus 6n minus 5. So 3n square will cancel. So the difference becomes 6n minus 3. Alright, so now we can check and confirm that there is a n present in this equation. So the difference has a term n in it. So therefore your conclusion is not arithmetic progression. Okay, so this is how we check whether a given sequence is in AP or not. Okay, next. The next concept is to find out the any general term in AP. Okay, so this is general term in arithmetic progression. So already we have noted one thing, that the AP is in the following format. That is, when I start from the first term of AP, right? Okay, I'll split this into two parts. So the first concept that we are going to look here is the nth term from beginning. Nth term of AP from the beginning of AP. Right. If you want to calculate the nth term, this is a very standard term. So we will call this is Tn. Tn is equal to A plus n minus 1 into D. Okay. So this is, for me, I will denote this as L, easy to remember, as the last term in case of finite. Okay. If at all I'm looking at the finite AP, then the Tn can be considered as the last term. That's why I denote it as L. But anyway, all books say that this is nth term, say Tn. Alright, my next one, what if I want to find the nth term of AP from the last? Right, I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this is considered as the first, and I want to calculate this is the nth from last, right? Still I should be able to do that, right? That's why the second type is, right, the I want to find the nth term of an AP from the end. So how to find that? It is also pretty straightforward and very easy, right? So what is the first term from the end, right? So I can write, say, write L. So I'll write the, okay, let me write in this way. First term from end. I will call this is T, maybe 1, T1 dash, because normally T1 is given to the first term. That is the normal convention from left to right. Now I'm talking about the last term. That is nothing but L as per our equation. Okay, so that is L itself, right? Then what should be the second term from the end? I will call this is T2 dash. This is L. From L you subtract D to come back. Correct? From A, if you start from A, it is A plus D, A plus 2D, and so on. So second term is like this. So the third term, right, from the end has to be T3 dash. This should be L minus 2D. In the same way, if I want to calculate the nth term, this is the nth term from end. Tn dash is my notation. This is L minus n minus 1 into D. Very straightforward. Just remember what is L. L is the last term that is denoted by Tn, right? Use the equation Tn to find the last term, right? So that last term minus n minus 1 into D. If you want to go from the first to last and calculate the nth term, this is A plus n minus 1 into D. And, right, you can use this notation. And now you think what should be the last term, right, from the end. From the end, if you come back, what is the last term, right? This is normally the first term of AP, right? So because from the first I told that the last term, so Tn dash has to be A for us because A is the first term, right? When I come to the nth term from this, I should be getting this. Now let us try to do calculate a different thing. So this is the answer. Tn dash is equal to this. This is the last term from. This is the nth term from the end. Now let's make a very simple calculation. So this helps us in solving many other problems. So let me do a calculation that is Tn plus the Tn dash. So what is Tn? Tn is A plus n minus 1 into D. So that is the Tn. I'm going to write like this. This is the formula for that. Okay, now, so there is a plus. So plus, write the Tn dash. That is L minus n minus 1 into D. So this is actually a substitution that I'm going to do for Tn dash, and this is the answer for that. Okay, so let us simplify this further. I can understand that the plus n minus 1 into D and minus L minus 1 into D will cancel, right? So the first term and the last term is basically, right, this is nothing but this is A plus L. Obviously, Tn, nth term is L, Tn dash is A, right? So you see you are getting back the same thing, right? So this is just a verification as well, right? Also you can apply this to solve many of the problems. We'll see that later. Okay, so this is just a verification. You can even take this as a note. Okay, and there are some other terms. This, let's say this, take this is the note number 1. Okay, then we'll go to note number 2. The common difference in an AP can be identified like this. D is also equal to the L minus A divided by n plus 1, right? Where A is the first term, L is the last term, and n is the number of terms in AP. So here L and A are known to us. N is the number of terms in AP. Right. Now, another point to remember with respect to the with respect to AP, right? Let's say if we have the terms like Tn, comma, Tn plus 1 and Tn plus 2 uh, are in AP. So this means they are consecutive terms. Present term, next term, and it's the next term. So three terms are given, and let us assume that they are in AP. Then there is a condition that, so this implies that the common difference should be same. That is Tn plus 1 minus Tn should be equal to Tn plus 2 minus Tn plus 1, isn't it? So let me take the Tn plus 1 to the same time. So what is Tn plus 1? That's the midterm of the three. So Tn plus 1 and this Tn plus 1 coming to this side, it makes it 2 times Tn plus 1. So that means 2 times uh, 2 times the Tn plus 1 should be equal to, there is a positive term Tn plus 2, that's the last term, the third term, plus the first term. First term is Tn. So this is one very important rule that is associated with uh, the arithmetic progression and the three consecutive numbers in AP. Only when we have three consecutive numbers in AP, this is valid. This is one very important factor, right? In general, I can rewrite this as, instead of Tn plus 1, I can write in terms of simple ABC. So if A comma B comma C are in AP, then it's understood that 2 times the midterm 2B is equal to first term plus last term. Otherwise, the midterm is equal to first plus last by 2. Okay, so even this is very useful when it comes to the solution of problems associated with the sequence or the arithmetic progression. Okay, all right. So let's go for a question based on all the concepts we discussed so far. All right. So the question is, find the first negative term of AP, that is 20, 19, 1 by 4, 18 half, 17, 3 by 4, and so on. So the question is to find, anyway, this is decreasing uh, AP because I can understand that the D is equal to, right, minus of 3 by 4. It's reducing. So I know that this is a decreasing AP. So ultimately the terms are going to be negative. What is that term? Negative term. Find the first negative term of this AP is the question. So I know that this implies, according to this question, my point is to find when the TM becomes less than 0. Right? So what is Tn? Let me write the Tn, that is the last term according to me. I want to check that when it becomes negative. So A plus n minus 1 into D should be, let me, you can even equate to 0, doesn't matter, right? Let me say it is less than 0. So substitute, first value is 20 plus, let me keep n minus 1 as it is for the time being, into D is equal to minus of 3 by 4 should be less than 0. Okay, so let me multiply by 4 throughout, right? That makes the first term as, okay, 4 into 20 is 80 minus, this is, I'll multiply, this term becomes, since n minus 1 into 3 by 4, I will not get a 4. So 80 minus, there is n into minus 3. So I have minus 3n. Then minus 1 into minus 3 is plus 3. So 4 cancels, right? This number should be less than 0. All right. So this means minus 3n plus 83 is less than 0, right? So minus 3n, this plus 3 goes to other side as minus less than minus 83. So when you try to cancel minus on both sides of a lesser than symbol, it changes, right? So this means 3n should be greater than 83. So that's a rule in mathematics. When you cancel the terms on both sides of, if it is equality, no problem. If it was equal, it remains as it is. But if it is less than, it becomes greater than. Or if it was greater than, this changes to less than. So that's one important step here. Therefore, n should be greater than 83 divided by 3. So this has to be the closest integer, which is closest next integer. So if you do the calculation, 83 by 3 is actually 27.66, right? So this is, right, this should be greater than this. So let us approximate n to 28 because n has to be an integer. So this is actually, right, equal to 27.666, right? So since I want n has as an integer value, I'll take the next number. It has to be greater than, so 28. All right. Now, therefore, let's calculate the T28. T28 is equal to first one, that is 20, plus this is 28 minus 1, that is 27, into this is minus of 3 by 4. So let us calculate this value. So this is 20 right. So when we calculate and this comes to be minus 1 by 4, obviously this is the first number. Okay, first number on the negative side. All right, let's move to the next question. Right, this is if nth term of AP is 1 by n and the nth term is 1 by m, find the mth term of AP. Right. So we have AP and it is given that the mth term is 1 by n and nth term is 1 by n. Right. So how to find the mnth term? Right. That's the question. Okay. The first approach is that let us assume we don't know what is the first term, what is the last term, etc. Right. Because of that, right, you can assume it in this way, right? This is something like, let us say we have two constants with us, right? And if you want to calculate the, say, okay, I'll write in this way. So if, let me assume that we have two constants with us, A and B, right? They are the two terms, okay, are the constants. This implies if you want to find any rth term in AP can be calculated as, say, denoted by TR is equal to, this is A into R plus B. So this can be the first number, this can be the difference, and you can write R over there. Okay, any term, any number. R can be 1, 2, 3, 4, etc. Okay, so like that I can calculate. This is the general representation, provided we do have no idea, right? I'll tell you another alternative way which makes more sense, but this is also going to work. This is the fastest one, easiest one to get the answer. So in this case, you see they have given something that is mth term is 1 by n. So that means Tm is equal to 1 by n. This is equal to A times m, because mth term plus b. Okay, so this implies I can write this is equal to 1 by n. So call this is equation number 1. Okay, also they have mentioned that the nth term is 1 by m, correct? So I can write A times n plus b should be equal to 1 by m. So this is equation number, what is that? That's 2. Okay, if I subtract one from the other, right? If you can solve it in any way, right? We can try to solve this. Maybe I'll perform one minus 2. So when I subtract b cancels, so this is a times m minus n is equal to first one minus second one. So this is 1 by n minus 1 divided by m. So a into m minus n is equal to, this is m minus m minus n over mn. Okay, m minus n will cancel on both sides. That implies what is a? Therefore, a is equal to 1 divided by mn. Okay, that's first thing. Then this implies find what is b. Okay, so therefore, let me use the first function. So a is equal to 1 divided by m n into, so the first equation I'm writing, a into m plus b is equal to 1 by n. You can see that m cancels, 1 by n and 1 by n will cancel. So b is equal to 0. Alright, so we got the values of a and b. Therefore, mnth term, right? This is the question. Find the mnth term. So what is the mnth term? This is t mn. According to our case, this is a. What is a? A is equal to 1 divided by mn. A times r is nothing but the rth term. Now it is mnth term plus b, which is 0. So you can see mn cancel, so the answer is 1. So this is the answer present in one of the 4 options. So answer is equal to 1. Okay, this is approach number 1. So I'll tell you another approach which you can try by yourself later. So this is start, let assume. So this is method 2, optional. If you want, you can try this. So you assume that let the starting term be a and let there be a common difference d, and you write therefore the general term tk is equal to a plus k minus 1 into d. Alright, then you write therefore the mth term, because mth term is given, so tm is equal to, write an equation and equate that to 1 by n. So then also you write nth term, tn is equal to something, equate it to 1 by m. Now using this you can find a and d, then later on you find tmn, right? Get the equation, substitute, and you will find that also equal to 1. Okay, this is the alternative method or the second method to solve this question, right? This is slightly longer than the previous technique, but you will get the same answer ultimately.